Hey everyone, and welcome! Today we are tackling a term that you've probably seen 1,000 times, but maybe never really dug into: IOPS. It is, and I'm not exaggerating here, the secret ingredient that really dictates how fast your storage feels. And by the time we're done here, you'll see why this hidden number is often way more important than the big speed numbers you see on the box. So let's jump in.
So tell me if this sounds familiar. You just got a brand new, powerful server. It's packed with RAM, it's got a killer CPU, but when you actually put it to work, it just feels laggy. And you're sitting there scratching your head thinking, what gives? Well, the answer probably isn't the CPU or the RAM. It's almost always the unsung hero, or, the villain, of your system's performance, your storage. Okay, to really get what's going on, I want you to picture your storage, your hard drive, your SSD, as this gigantic library. And its performance? Well, that all comes down to the librarian working inside. This librarian's job is to run around and grab every single piece of data your computer asks for. How fast they can do that and how many requests they can handle at once, that's the whole ballgame. And the way we measure our librarian's performance? That's IOPS. It stands for Input-Output Operations Per Second. Now, this isn't about how big of a book the librarian can carry. It's about how many different, separate book requests they can juggle every single second. Think of it as the ultimate measure of multitasking for your storage.
So that brings us right into our first section, the speed you don't see. We're about to pull back the curtain on why this invisible number is so much more important for real-world speed than the big, flashy numbers you see advertised. Right, so this slide really nails the difference. Throughput, the thing we usually see, measured in megabytes per second, that's like asking our librarian to go get one single giant encyclopedia. It's one task, and it's all about how fast they can lug that one heavy thing back. That's great for stuff like video files or huge backups. But IOPS, that's completely different. That's like giving our librarian 1,000 sticky notes and telling them to fetch a tiny piece of information from 1,000 different books scattered all over the library. It's a chaotic storm of small, random requests. And that is exactly what things like databases or busy websites do all day, every day.
Okay, so let's move on and see how this plays out in the real world. We're diving into the huge difference between those old-school spinning hard drives and modern solid-state drives. Because believe me, they play by completely different rules when it comes to IOPS. And here is the fundamental divide. A hard disk drive, an HDD, is a mechanical relic. It's got spinning platters and a little arm that has to physically move back and forth. Our librarian is literally running across the library floor. Its speed is limited by physics, how fast that arm can move and that disk can spin. But an SSD, it's pure electronics. Our librarian suddenly has a teleporter. They can instantly be anywhere in the library. There are no moving parts, just electricity. The only limit is how fast the controller chip can think.
And because those HDDs are mechanical, you can actually calculate their IOPS based on physics. You've got seek time, that's the time it takes for the arm to move to the right spot. And then you have rotational latency. That's waiting for the spinning platter to bring the right data around to be read. You literally add those delays together, and that's how long one operation takes. It's kind of neat, but man, is it slow.
So, what about SSDs? How do you calculate their IOPS? Well, you don't, because there are no moving parts, there's no seek time, there's no rotational latency. The whole concept is irrelevant. The performance is so ridiculously, mind-bogglingly higher that the manufacturers just test them in a lab and tell you the number. Our librarian with the teleporter is just too fast to even bother trying to time with a stopwatch.
And let's put some real numbers on this, because this is where it gets crazy. Look at this. Your standard desktop hard drive might get you maybe 100 IOPS on a good day. Even a super fast screaming 15,000 RPM enterprise drive barely cracks 200. Then you jump to a basic SSD, and we're at 75,000 IOPS. And a modern NVMe drive, we are talking 500,000 IOPS or more. It's not just an improvement, it is a completely different universe of performance.
All right, so we know what IOPS are, and we know SSDs are the undisputed champs. But where does this actually matter? In this next section, let's look at the real-world situations where high IOPS isn't just nice to have, it's absolutely essential. Think about database servers, especially for something like an online store. You've got thousands of little transactions hitting it every second. That's pure IOPS. Or what about VDI, virtual desktops? Picture this. It's 9 a.m. on Monday, and 100 people all try to log in and boot up their virtual computers at the exact same time. That creates what we call a boot storm, a tidal wave of tiny file requests.
Busy web servers, email servers, it's all the same story. The common denominator is a huge number of small random requests that would absolutely cripple a spinning hard drive.
Okay, now for a topic that is so important if you manage any kind of server, the RAID write penalty. We all use RAID to keep our data safe if a drive dies, right? Well, that safety has a hidden cost, and it hits your write performance hard.
So ask yourself this right now. Are you using RAID? Because if the answer is yes, the actual number of write operations your storage can handle might be half, or a quarter, or even a sixth of what you think it is. This is a gotcha that trips up so many people. And here's why. For every single time your server says, hey, write this piece of data, the RAID system has to do extra work. With RAID 1 or 10, that's simple mirroring. The data just gets written to 2 drives instead of 1. So 1 server write equals 2 disk writes, a penalty of 2. But with RAID 5, it gets way worse. To maintain its parity data, it has to first read the old data, then read the old parity, then it can finally write the new data in the new parity. That's 4 operations on your disks for 1 single request from the server, a penalty of 4. And RAID 6, with 2 sets of parity, an insane write penalty of 6.
This brings us perfectly to our next big question. Knowing all of this, how in the world do you figure out how many IOPS you actually need? Let's talk about sizing your storage the right way right from the start.
So here's the key takeaway. You can't just look at what your application needs. You have to factor in that write penalty we just covered. A really useful, simple formula is this. Take the number of reads you expect and add it to the number of writes you expect. But first, multiply those writes by your RAID penalty. That total is the real number of IOPS your disks need to be able to handle.
And just to give you a feel for what that looks like, here are some typical ranges. A basic web hosting setup might be fine with a few hundred IOPS. A pretty busy database could easily need a few thousand. But a VDI environment, as we talked about, can get into the tens of thousands of IOPS, especially during those peak login times. This is exactly why you have to know your workload before you even think about buying storage.
All right, let's bring it all home. In our final section, we'll cover the most important takeaways, and I'll give you some actual tools you can use to put all this knowledge into practice.
So if you want to know what your current system can do, please don't guess, measure it. There are some fantastic free tools out there. FIO and Iometer are the big, powerful industry standards that let you simulate all kinds of crazy workloads. But for a super quick and easy check on any Windows PC, Crystal Disk Mark is your best friend. It'll give you a great snapshot of your drive's performance in just a few minutes.
And as you get deeper into this, you have to remember these 3 things. An IOPS number by itself means nothing. First, the block size matters. A drive that's great at tiny 4K file operations might be terrible at 64K operations. Second, what's the read/write mix? A system that's 70% reads has totally different needs than one that's 50-50. And finally, is the access pattern random or sequential? Because random access is the true killer for performance.
I think this quote just says it all, doesn't it? It's so easy to get wowed by those huge megabyte per second numbers on the box. But for almost everything that makes a system feel fast and responsive, it's the humble, hard-working IOPS that's actually doing all the heavy lifting.
And I'll just leave you with this one last thing to chew on. We're seeing new technologies now, things like storage class memory, that are almost as fast as your computer's main RAM. As those traditional storage bottlenecks just melt away, are we going to get to a point where performance is so fast, so instantaneous, that measuring operations per second just doesn't even make sense anymore? It's a pretty exciting future to think about. Thanks for tuning in.